Welcome to my class 12 Physics, first chapter, Electric Charges and Fields, and main point of discussion today, that is derivation of Coulomb's law from Gauss law. You know Coulomb's law. Coulomb's law means that is force means that is the electrostatic force between 2 point charges is directly depend upon magnitude of both the charges and inversely proportional to square of the distance between the two charges. And you also know Gauss law. Gauss law is equal to Gauss law, that is total electric flux. Phi means electric flux. You also know the meaning of electric flux. Electric flux means, suppose we take a area element, suppose this one is a small area element, and these are the electric field lines, and electric field lines suppose perpendicular to the small area element, then number of electric field lines crossing normally through this small area element is known as electric flux. And total electric flux is equal to sum of vector E dot del S vector. You know this formula. This is the Gauss law. And your del S vector, this is known as the area vector. Del S vector, this is the area vector. And E vector, that is the electric field. That is electric field intensity, and this is a dot product. This is a dot product between the two vectors, so that here theta is the angle between vector E and del S vector. Similarly, Coulomb's law in scalar form, and for free space and in SI unit, Coulomb's law, that is force F is equal to 1 divided by 4 pi epsilon 0, magnitude of first charge, that is Q1, magnitude of second charge, that is Q2, divided by R square. And we will derive Coulomb's law from Gauss law. This one is the Gauss law and this one is the Coulomb's law, and here we will derive Coulomb's law from Gauss law. Clear? We write heading derivation of Coulomb's law from Gauss law. And suppose we take a spherical closed surface. This one is the spherical closed surface. Closed surface means that is a three-dimensional surface. This one is the spherical closed surface, and this closed surface is known as the Gaussian surface. This is Gaussian surface. That is a closed surface, that may be your spherical surface, may be your cube, may be cylindrical, and this point is the center of the Gaussian surface. we write suppose O, and at the center a positive charge is there, that is plus Q, and this point we write A point. We join from center up to A, and this one is the radius of the Gaussian surface. Then at point A, what is the direction of the electric field? You know, direction of electric field or electric field intensity is always outward from a positive charge. That means this is the direction of electric field. This is the direction of electric field, that is E vector. Clear? And the total surface area of this Gaussian surface, we write S. And you know, in case of a spherical surface, S is equal to 4 pi r square. You know this formula. And here we take a small surface area. This one is a small surface area or small area element. We take a very small area element and we write that is del S. Del S is a small area element. Then what is the area vector? We draw a perpendicular or we draw a normal to the small area element. This one is the normal to the small area element, and that is known as area vector, del S vector. And here area vector is a outward normal, and electric field at point A, that is also outward direction, so that both electric field and area vector in the same direction or parallel to each other. If parallel to each other, then angle between E vector and del S vector, we write that is theta. Theta is equal to 0 degree in this case. Clear? Then we write at point A, or for this small area element. For this small area element, what is the flux? We write flux for small area element del S is, from Gauss law we write that is del phi, because area element, that is del S small, so that flux is also small. For a small flux we write del phi, and del phi is equal to, you know the formula, that is E vector dot del S vector. That implies we write del phi is equal to E del S cos theta, and here theta is equal to 0 degree, and cos 0, you know, value is equal to 1. That implies you write del phi is equal to E multiplied by del S. This is the flux for small area element del S. And for the whole Gaussian surface or for the whole spherical surface, what is the flux? We write for total surface area, flux means that is the electric flux. Flux is, that is phi, and phi is equal to sum of all the small flux, that is del phi, and this is for all del S. Clear? That implies we write net flux phi is equal to sum of, in place of del phi we write E, this is the formula, in place of del phi we write E del S, we write E multiplied by del S. That implies phi is equal to, here electric field at point A, electric field at point A, that is a constant. Why? Because charge plus Q, that is a constant, and the distance between center to observation point, that is also constant. In this case, that is R. So that electric field at point A is a constant. If electric field at point A constant, then we take electric field out of the sum. So that we write that is phi is equal to E multiplied by sum of all the small area element, and we write phi is equal to E sum of all the small element, that is S. And what is S? S is the surface area, total surface area of the spherical surface, and you know the formula, that is S is equal to 4 pi r square. So that we write phi is equal to E multiplied by 4 pi r square. Suppose this is equation number 1. Again, from Gauss law, we know phi is equal to net charge enclosed inside the Gaussian surface or inside the closed surface, that is Q, divided by epsilon 0. This is the statement or mathematical expression of Gauss law. Suppose this is equation number 2. And if we compare equation 1 and 2, in equation 1, left hand side, that is phi. In equation 2, in left hand side, phi is also there. So that both the equations are same. That means from equation 1 and 2, we get, from equation 1 and 2, from equation 1 and 2, we get equation 1, that is we write E multiplied by 4 pi r square, that is E multiplied by 4 pi r square is equal to equation 2, that is Q divided by epsilon 0. We write Q divided by epsilon 0. That implies E is equal to, we take 4 pi r square to the right hand side. This is 1 divided by 4 pi r square Q by epsilon 0. Or we also write E is equal to 1 divided by 4 pi epsilon 0 multiplied by Q by r square. This is the magnitude of electric field. This is the magnitude of electric field intensity at point A. Then what is the force? Look at the figure. Suppose here we placed another charge at point A. Suppose we placed a unit positive test charge plus Q0 at point A. Suppose we placed another charge, that is plus Q0, and at the center one charge is there, that is plus Q. At point A, charge is there, that is plus Q0. Then what is the force applied between these two charges? We write force applied between these two charges. Force applied on Q0 due to plus Q charge is equal to, we know the formula for force F is equal to electric field multiplied by charge is Q0, so that we write F is equal to E multiplied by Q0. That implies we write F is equal to E is the electric field, and this is the expression of electric field. In place of electric field, we write 1 divided by 4 pi epsilon 0 Q divided by r squared multiplied by another charge, that is Q0. That implies F is equal to 1 divided by 4 pi epsilon 0 Q0 divided by r squared, and this is the Coulomb force. This is the expression of Coulomb force between two charges. This one is the first charge and this one is the second charge. We write this is Coulomb's law. This is Coulomb's law, and this is all about derivation of Coulomb's law from Gauss law. And in the next class, we will discuss about some application of Gauss law. And thank you.